Hello, my name is Troya and I am research engineer working at the INEXM group in University Clinic Würzburg, Germany. I have the pleasure of briefly talk about our recent published article, Direct Comparison of Multiple Computer-Aided Polyp Detection Systems. Up to date, more and more, computer-aided polyp detection systems are being implemented in the clinical setting. Different randomized trials have shown that these systems lead to an increase in the adenoma detection rate among endoscopists, primarily attributed to the enhanced detection of diminutive adenomas. Artificial intelligence systems are very sensitive to the type of data they are trained on, and specifically learn its features. In addition, each device available on the market has been validated with a different dataset, and therefore direct comparisons between devices cannot be made. Another issue is that different manufacturers perform device updates or offer customizable detection thresholds. Little is known about the effect of this on their performance. Therefore, the aim of this study was to direct compare three computer-aided polyp detection systems using the same benchmark dataset, GI Genius, Endo8, and our freely available polyp detection system, Endomine. In addition, we also compared two different updates of GI Genius, from now on version 1 and version 2, and also evaluated the performance of two different detection thresholds of Endo8, Type A and Type B. A total of 101 colonoscopy videos were processed by each of the systems and modes. The coordinates of each frame containing a polyp were manually annotated. Thanks to an algorithm developed to detect the bounding box output of each of the systems, we were able to compare them with the manual annotations. Sensitivity was our first outcome. All the systems detected all the polyps, meaning 100% per polyp sensitivity, except of GI Genius version 2 that missed a sessile serrated adenoma of Paris type 2A, and Endo8 type B, which also missed a Paris type 2A polyp that was present for less than a second in the screen, and that was also missed by the endoscopist performing the examination. If we consider the per frame sensitivity defined as the ratio of the number of correct identified images containing polyps and the total number of images of that particular polyp, GI Genius version 2 showed the best performance in our dataset with 67.85% of the frames containing polyp correctly detected. False positive rate was a secondary outcome analyzed in this study. Endo8 type B showed the best performance, leading as well to the lowest number of false positive frames. Regarding the first detection time, defined as the necessary polyp time that a system needs to trigger a correct detection, GI Genius version 2 was the fastest detecting a polyp in our dataset with a mean time of 607 milliseconds. Last outcome that we measured was intersection over union. Intersection over union measures the accuracy of the predicted bounding boxes by comparing the overlap of the bounding box of the detection system and the manually annotated bounding box. Endomine showed the highest mean intersection over union value in our dataset, 68.32%. In this study, we have compared to our knowledge for the first time the performance of multiple computer-aided polyp detection systems in the same dataset. We also have shown the impact of different software updates and different detection thresholds. In this sense, we have identified that the later version of GI Genius is significantly more sensitive than the first version and needs less time to detect polyps. In addition, our study confirms the high sensitivity of Endo8 type A reported in other studies and the high specificity of Endo8 type B. Lastly, Endomine, a freely available computer-aided polyp detection system developed at our university clinic, had a similar performance than commercially available systems. Thank you very much for listening.